Hello again. We are moving on in our discussion of derivatives and differential calculus. We're going to talk about how to find the equations of tangent lines. This is lesson 12.5, so let's get started. In the previous lessons, we were able to calculate the gradient or the slope of the tangent line if we knew the x-coordinate of the point I was dealing with. But now I want to find out the actual equation of that line. Okay, so here's how I do it. The first step is going to be, I'm going to call that x-coordinate x1. Then what I'm going to do is I'm going to plug x1 into f of x and call the y value y1. I'm going to find the derivative. I'm actually just going to take the derivative of f of x, call it f prime of x, and then I'm going to plug x1 into that and call the gradient m. And then I'm going to plug x1, y1, and m into the point slope or point gradient form, which you've seen before, and that will give me the equation of the line. So let's go through some examples first. It always makes it easier to go through some examples. So let's say I've got this function here, f of x equals x cubed minus 3x squared minus x plus 3, and I want to know the equation of the tangent line at x equals 2. Well, step one, I'm going to let x1 equal that 2. That's the x-coordinate I'm dealing with. I'm going to plug that into the original function, and when I do that, I do a bunch of calculations, and I get that y1 is negative 3. So that's the y-coordinate. You can kind of see that from the graph. That's where that blue point is. It has a y-coordinate of negative 3. Now I'm going to find the derivative. I know how to do that. The derivative of x cubed gives me 3x squared. The derivative of minus 3x squared gives me minus 6x. The derivative of minus x gives me minus 1, and the derivative of the plus 3 at the end gives me 0. So the derivative of that entire function is 3x squared minus 6x minus 1. So all I need to do now is plug in the x that I'm dealing with, which is x equals 2. I plug that in, and I get negative 1, which means that the slope of the tangent line is negative 1. Well, now I have a point, 2, negative 3, and I have a slope, or a gradient, which is negative 1. So I can use point gradient form. I plug it in. So x1 in that equation is going to be replaced with 2, y1 is going to be replaced with negative 3, and m is going to be replaced with negative 1. So that is the equation right there of the line that passes through that point, and it has a slope that is tangent to the curve at that point. All right, so let's do another example. Slightly trickier. Where does the tangent line at x equals 0, same function, so where does the tangent line at x equals 0 touch the x-axis? Alright, so we're now going to let x1 equal 0, that's the x that I'm dealing with. If I plug that into the function I was given in the last slide, I get 3. So the y value of that point is 3. I can kind of see that just by looking at the graph. The derivative hasn't changed. It's still 3x squared minus 6x minus 1, just like it was in the last example, because it was the same function. If I plug in 0, I'm going to get negative 1. So the slope of my tangent line, or the gradient of my tangent line, is going to be negative 1. So plugging that in, I've got x1 equals 0, y1 equals 3, and m equals negative 1. I plug all of that into the point gradient form, and I get y minus 3 equals negative 1 times x minus 0. Now that's not the end of the problem, because I need to know where that touches the x-axis. So I take that equation, there it is. I need to know where does it touch the x-axis. Well, that just means I need to set y equal to 0 and solve for x. So replacing y with 0, that's the equation I get. Simplifying things on both sides, I get that negative 3 equals negative 1x, and dividing both sides by negative 1, I get that x equals 3. So this graph, this tangent line, crosses the x-axis at x equals 3. And you can kind of see that it does that where that red dot is. So if you have any questions about finding the equation of a tangent line, please let me know, and I will see you tomorrow.